The topic of this video is building quadratic models from verbal descriptions, economic models. Let's look at a problem. The price P and the quantity X sold of a certain product obey the demand equation P equals negative 1/3 X plus 40, with 0 is less than or equal to X is less than or equal to 120. Okay, this problem has parts A through E, and as economics problems go, this one is a little bit on the easier side, a little bit shorter, a little bit easier than a lot of the other problems of this type. Okay, let's begin with part A. Express the revenue R as a function of X. Well, that's actually pretty easy because we know that R equals X times P, and we're given everything we need. For example, we're told that P is equal to negative 1/3 X plus 40. So replace P with negative 1/3 X plus 40, distribute, and rewrite R as R of X, because it says to express R as a function of X. So we get R of X equals negative 1/3 X squared plus 40X. All right, part B, what is the implied domain of R? Well, that's actually really quite easy. Looking at this equation, there are no even radicals or logs, and the only denominator is a 3, which is not 0. So, looking at the equation only, we would conclude the domain is all real numbers. However, domain is a collection of the x's, and it says right in the problem that x must be between 0 and 120, so my domain is just going to be bracket 0, comma, 120, bracket. Part C, what is the revenue if 66 units are sold? All right, well, we can get that pretty easily just by plugging into our equation. Everywhere we see an x, we're going to put a 66. So R of 66 is equal to negative 1/3 times 66 squared plus 40 times 66. Following order of operations, we should do 66 squared first, which is 4356. Okay, next we'll deal with this fraction. Multiplying by 1/3 is the same as dividing by 3, so we'll divide this by 3, and we'll remember our negative. So this is negative 1452 plus 40 times 66, which is 2904. And when we do the addition, we get 1452. 1452 what? Well, this is our revenue, so this is money. This is $1,452. All right. In our next video, we will finish this problem by doing parts D and E.